We've witnessed various breakthroughs in AI, from generating text to crafting images, and even producing videos and 3D models out of mere text. It's wild to think about the challenges involved in transforming a sentence into a lifelike 3D object, complete with all its intricate details. But guess what? We've got a game-changing AI model to talk about today, and it's called MVDream. MVDream can take a simple text description and turn it into a top-notch 3D model that looks incredibly realistic. Pretty cool, right? But hold on, it gets even cooler when you dive into how it all works. Let's take a closer look. Intro to MVDream. All right, let's break down the challenge of 3D models in a simpler way. When you're dealing with 3D models, the trickiest part is making sure they look realistic and high quality from every angle. Think of it like this. You're looking at a 3D object, and it should look right no matter which way you turn it. It's kind of like avoiding those funny four-eared Yoda figures or odd-looking multi-phase subjects. This happens because most image datasets don't have people's backs in them, so the model tends to focus on faces. To make 3D models, one common method is to mimic what a camera would see from different angles and generate images accordingly. This is known as 2D lifting. You start with regular images and combine them to create a full 3D scene. Sounds good, right? But here's the catch. The model usually generates one view at a time, and it struggles to grasp the complete 3D picture. Now, here's where MVDream steps in and changes the game. They tackled something called the 3D consistency problem, and claimed they cracked it using a technique called score distillation sampling. Wait, how does MVDream work? Now, let's dive into the nitty-gritty of their approach, starting with the architecture they've chosen. In a nutshell, it's like another one of those 2D image diffusion models you might have heard of, such as DALL-E, Midjourney, or Stable Diffusion. What they did differently, though, is they kicked things off with a pre-trained Dream Booth model. This Dream Booth model is a powerful open-source tool known for generating images using Stable Diffusion. Here's where it gets interesting. Instead of just creating one image, they set out to craft a bunch of multi-view images directly. How did they do it? Well, they took a 3D dataset filled with various objects and pulled multiple perspectives from these objects to train their model to recreate them in reverse. To make this happen, they tweaked the self-attention block in the model, turning it into a 3D version. This adjustment allowed them to generate not just one, but multiple images simultaneously. To keep things organized, they even included information about the camera angle and time step for each view. This helped the model understand where each image should go and what kind of view it needed to generate. Pretty cool, right? But how does MVDream put the images together? Now let's see how they connect all those images and make them work together to understand the bigger picture. Imagine these images as pieces of a puzzle, and they need to collaborate to get the full picture. So, they're all generated simultaneously, allowing them to share information and get a better grasp of the overall content. Once you've got this ensemble of images, you feed in your text, and that's when the magic happens. The model goes to work, learning from a dataset and accurately reconstructing objects. This is where they put into action their multi-view score distillation sampling process that I mentioned before. So now they've got a multi-view diffusion model capable of producing different angles of an object. But here's the twist. They didn't stop at just generating views. Let's try to understand the NERF model a little more. Their goal was to create consistent 3D models, not just those individual perspectives. To achieve this, they took a page from the playbook of NERF, or neural radiance fields. Here's how it works. They take their trained multi-view diffusion model and essentially put it on pause. It's not learning anymore, just being used as a tool. Then, they kick things off by generating an initial version of the image. This initial version is guided by your text description and some initial rendering, but they also add a dash of noise to the mix. This noise serves as a nudge to the model, letting it know it needs to create a slightly different version of the image, while keeping the context in mind. How is this used to generate images? Next up, they use this model to generate a higher quality image. They then blend this new image with the one they initially created and remove the added noise. This result becomes a guiding light for improving their NERF model in the next step. All these steps help them better understand where the NERF model should focus its attention to produce even better results. They repeat this process until they're satisfied with the 3D model they've crafted. And voila, that's how they took a 2D text-to-image model, adapted it for multiple view synthesis, and ultimately transformed it into a text-to-3D model. It's like teaching a model to see the bigger picture, one step at a time. There are still limitations to this 3D model. The generated outputs are currently limited to a resolution of 256 by 256 pixels, which, while impressive, is relatively low resolution. Also, the size of the dataset used for this task poses a limitation when it comes to the model's ability to generalize its learnings. In today's digital landscape, 3D models are invaluable to various professionals, including digital artists, architects, engineers, and game developers. Yet creating these intricate digital objects often involves a time-consuming and complex process. This cutting-edge technology can transform reference text or images into intricate 3D designs, potentially revolutionizing the creative and design industries. Reflecting on AI solutions for 3D models. The current generation of 3D model-generating AI typically begins as text-to-image algorithms. The automation of 3D image generation holds the potential to streamline numerous workflows. Artists could develop games or create digital scenes at a much faster pace, significantly reducing the time spent on model creation, especially in the realm of movie production. Additionally, construction projects could benefit from shortened timelines as architects generate 3D blueprints more efficiently. However, it's essential to address certain concerns associated with these algorithms. AI-generated art, as a whole, has faced criticism because some artists' work has been used in training datasets without their permission, giving rise to copyright and ethical complexities. We've explored the intricate process behind MVDream, from its multi-view image generation to the clever techniques like score distillation sampling. This technology has the potential to revolutionize the way we create and visualize 3D content, making it more accessible and efficient. However, it's important to acknowledge the current limitations, such as resolution and dataset size, and the ethical considerations surrounding AI-generated art. As the field of AI continues to evolve, we must strike a balance between innovation and responsibility. Until then, make sure to check out this next video about how AI is being used in healthcare.